Hey everyone, this is a lecture series for proportion chapter from ICSE 10th Maths. We were doing the sums from ML Aggarwal from exercise 7.2. In the previous video we did till question number 17. Today we are going to start from question number 18. This is your own channel Arpita Classes and my name is Arpita Banerjee. Let's start with the 18th sum. So if Ax is equal to By is equal to Cz, prove that x square upon yz plus y square upon zx plus z square upon xy is equal to bc upon a square plus ca upon b square plus ab upon c square. So this is what is given to us. So let us consider Ax is equal to By is equal to Cz is equal to k. All these ratios are equal and we are considering that's equal to k. From here I'll write Ax is equal to k. So x is equal to k upon a. In the similar pattern I'll write By is equal to k. So y is equal to k upon b. And similarly Cz is equal to k. So z is equal to k upon c. Now let us take the left hand side. Left hand side is x square upon yz plus y square upon zx plus z square upon xy. Now, in place of x, we are going to substitute k upon a. So it will be k square upon a square. In place of y, we are going to write k upon b. So that's k upon b. Into in place of z we are going to write k upon c, so it's k upon c, plus y square would be k square upon b square, z would be k upon c, into x is k upon a, plus z square, that's k square upon c square, x is k upon a into y is k upon b. So we just substituted the values of x, y, z. Now k square and k will get cancelled. So we are getting 1 upon a square bc. So if I write it here, in this place I am writing so that you can see properly. It's 1 upon a square, 1 upon a square upon bc. This bc is down. So 1 upon a square upon bc plus 1 upon b square. This k square and k will get cancelled. So it is 1 upon b square upon ca plus 1 upon, even this is getting cancelled, c square upon ab. Now in the next step, this bc will go up. So it will be bc upon a square plus ca upon b square plus ab upon c square. Now if you look at the right hand side, we got it already. bc upon a square plus ca upon b square plus ab upon c square. So that is equal to the right hand side proved. Let us proceed with the next sum. Question number 19. It's given that ABCD are in proportion. So prove that the first sub question is 5b plus 7b into 2c minus 3d is equal to 5c plus 7d into 2a minus 3b. Now there are few sub questions. We are just doing the first one. So ABCD are in proportion. I am writing it here. A upon b is equal to c upon d is equal to, let us consider k, because ABCD are in proportion. So we'll write A is equal to bk and c is equal to dk. Okay. Now let us take the left hand side. The left hand side is 5a plus 7b into 2c minus 3d. So 5 in place of a we are going to put bk, 5bk plus 7b into 2. In place of c we are going to put dk, 2dk minus 3d. From here I can take b common, so it is 5k plus 1. From here d common, so it is 2k minus 3. So if I write it in a proper manner, it will be b into d, 5k plus 1 and 2k minus 3. This is the left hand side. Now let us take the right hand side. Right hand side is 5c plus 7b into 2a minus 3b. Now 5 in place of c I am going to put dk plus 7d. In place of a I am going to put bk minus 3b. So from this I can take d common. If I take d common, it is 5k plus 7. Oh sorry, I took b common, it will be 7, not 5k plus 7 is there, I'm sorry. Okay, now here b common, so it is 2k minus 3. If I write it in a proper manner, it will be b into d, 5k plus 7, this is 7, into 2k minus 3. Now if you look at the left hand side and right hand side, we got the same thing in the left hand side and right hand side. Therefore it is, so you can write left hand side is equal to right hand side. Now the second sub question of the 19th question, you need to prove MA plus NB is to B is equal to MC plus ND is to D. It's again given the same thing, that is ABCD are in proportion. So let us take the left hand side. It's MA plus NB is to B, which can be written as MA plus NB upon B. Now in place of A, I will write BK. So it will be MBK plus NB upon B. From the numerator, we can take B common. So if I take B common, it is MK plus N upon B. B and B gets cancelled. So from here we get MK plus N. That is what we are getting from the left hand side. Now let us check the right hand side. Right hand side is MC plus ND is to D, which means MC plus ND upon D. Now in place of C, I am going to substitute DK. So it is MDK plus ND upon D. From the numerator, I can take D common. So after taking D common, I am getting MK plus N upon D. From here, D and D gets cancelled and we get MK plus N. So look at the left hand side and right hand side, we got the same thing from the left hand side and right hand side. Therefore, we can write LHS is equal to RHS. Proved. Now proceed towards the third sub question. It's given A4 plus C4 is to B4 plus D4 is equal to A square C square is to B square D square. So we already have A upon B is equal to C upon D is equal to K. So A is equal to BK and C is equal to DK. This already we have it. So let us take the left hand side. A4 plus C4 is to B4 plus D4. So from here we can write A4 plus C4 in place of S2 divided by B4 plus D4. Now in place of A, I will substitute BK. So it will be B4 K4 plus. In place of C, I would substitute DK. It is D4 K4 divided by B4 plus D4. From the numerator, we can take K4 common. So if I take K4 common, it is B4 plus D4 divided by B4 plus D4. From this, B4 plus D4 gets cancelled and we get K to the power 4. So this we get from the left hand side. Now let us proceed with the right hand side. A square C square is to B square D square, which means A square C square divided by B square D square. Now in place of A, we are going to write BK. So it's B square K square into C. In place of C, we are going to put DK. So it is D square K square divided by B square D square. From here, B square D square B square D square gets cancelled. So it's K square into K square. After applying the property of exponent, bases are same, powers we can add. So 2 plus 2 is 4. So we are getting K4 from the right hand side as well. So we can write left hand side is equal to right hand side. Proved. Next is sub question 4th of the 19th question. We need to prove A square plus AB upon C square plus CD is equal to B square minus 2AB upon D square minus 2CD. We have still been given that thing. So let us take the left hand side. a square plus ab upon c square plus cd. Now in place of a, I am going to put b square k square plus again bk into b. In place of a, I am going to put bk into b divided by c square. C square is d square k square plus dk into d. So from the numerator, I am getting b square k square plus b square k divided by, down I have d square k square plus d square into k. Now take b square k common from the numerator. So if I take b square k common, it will be k plus 1. Down I take d square k common, it will be k plus 1. K plus 1, k plus 1, k and k gets cancelled. So I get b square upon d square. So this is what I get from the left hand side. Now let us proceed with the right hand side. B square minus 2ab upon d square minus 2cd. Now b square can't be written anything, b square should be b square only, minus 2. In place of a, I am going to put bk, so it's bk into b divided by d square minus 2. In place of c, I am going to put dk, so it's dk into d. So it is b square minus 2b square k divided by d square minus 2d square k. Now from the numerator I can take b square common, so it will be 1 minus 2k, and down I can take d square common, it will be 1 minus 2k. So 1 minus 2k gets cancelled and I get b square upon d square. So if you look at the right hand side and left hand side, we again get the same thing, b square upon d square, b square upon d square. So we can write, therefore left hand side is equal to the right hand side, proved. So this is how we have to do all the sub questions of question number 19. I have done first 4 questions and I will do the last sub question. In between you have 2-3 more which you should try on your own. If you do not get, then maybe you can comment so that I can make another video to show you those sums. But you should try on your own. It's the same concept that we have to just put a, in place of a we have to put bk, and in place of c we have to put dk, and then take common and then simplify. So let me do the last sub question of question number 19. So this is the 8th sub question of question number 19. In between you have, I left 2-3 sums which you should try on your own. Let us start with the 8th sub question. Let us take left hand side, that is ABCD whole into 1 upon a square plus 1 upon b square plus 1 upon c square plus 1 upon d square. Now in place of a I am going to put, so here in place of a I am going to put bk, and in place of c I am going to put dk, right? So in place of a it is bk into b dk into d whole into 1 upon b square k square plus 1 upon b square plus 1 upon d square k square plus 1 upon d square. Now here I am getting b into b, that's b square, and d into d, that's d square, k into k, that's k square. Okay, now here what is the LCM? Here b square is there, k square is there, d square is there. So b square, d square and k square, this is the LCM. Okay, so here in the numerator it will be b square, k square is there, so in the numerator it will be d square plus. Here b square is there, so d square plus k square will come. Here d square, k square gets cancelled, b square will come. And here d square gets cancelled, so b square, k square will come. Okay. Now here you can see b square and b square, d square and d square, k square and k square gets cancelled. So I got d square plus. Now in place of d square, k square, I am going to put c square. Okay. So here c square plus b square. In place of b square, k square, I am going to put a square. So it is a square. Now if you arrange it in a proper manner, it's a square plus b square plus c square plus d square. Now look at the right hand side, we have a square plus b square plus c square plus d square. So that means we are getting left hand side is equal to right hand side. That's proved. Let us proceed with the next question, that is question number 20. If x, y, z are in continued proportion, prove that x plus y whole square upon y plus z whole square is equal to x upon z. So here they say that x, y, z are in continued proportions. What does it mean? It means x upon y is equal to y upon z is equal to, we'll take another alphabet, that is k. This means they are in continued proportion. X upon y is equal to y upon z, and this ratio will be equal to another ratio, that is k. So from here I can write x is equal to yk and y is equal to zk. Now since y is equal to zk, I'll put it here. So it is zk into k. So x is equal to zk square. So this is what I got from this information. Now let us take the left hand side. The left hand side is x plus y the whole square upon y plus z the whole square. Now in place of x I want to put zk square. So it's zk square plus y is zk the whole square divided by y plus zk. So zk plus z the whole square. Now let us take zk common from the numerator. So if I take zk common, it will be k plus 1. This entire thing has got a square. Down I'll take z common. So it is k plus 1 and this entire thing has got a square. Now from here, this if I do the square, it will be z square k square into k plus 1 the whole square upon this also z square into k plus 1 the whole square. From here z square gets cancelled and k plus 1 whole square gets cancelled. So we get only k square from the left hand side. Now let us process the right hand side. The right hand side is x upon z. Now in place of x, I'm going to put z k square and this is z. So z gets cancelled and get k square. So from the left hand side also we got k square. From the right hand side also we got k square. So we can write left hand side is equal to right hand side. Let us proceed with question number 21 now. If A, B, C are in continuous proportion, prove that PA square plus QAB plus RB square upon PB square plus QBC plus RC square is equal to A upon C. So if A, B, C are in continuous proportion, we get A upon B is equal to B upon C is equal to K. So from here we can write A upon B is equal to K or A is equal to BK. Similarly, B upon C is equal to K, so B is equal to CK. Put CK here, so it will be CK into K, so the value of A is CK square. Okay, now let us take the left hand side. Here the left hand side seems quite big. PA square plus QAB plus RB square upon PB square plus QBC plus RC square. Now, in place of A, I can put CK square, so it will be P CK square the whole square plus Q CK square into B is CK plus R, this is CK the whole square, down P B square that is CK the whole square plus Q into CK into C plus R C square. Now this is P C square k to the power 4 plus Q C into C is C square, K square into K is KQ plus R C square K square. Down I have P C square K square plus Q C square K plus R C square. Now from the numerator what I can take common is C square is there everywhere and K square. So I can take C square K square common. So it will be P K square plus Q K plus R. Down from the denominator I can take C square common. So it will be P K square plus Q K plus R. So from here C square and this whole thing is cancelled. So I get only K square from the left hand side. Now let us take the right hand side. Right hand side we have only A upon C. Okay, so A means C K square upon C. C gets cancelled, we get K square. So from the left hand side we got K square, from the right hand side also we got K square. So we can say left hand side is equal to right hand side proved. So children, we have done till question number 21 today. There are two more questions, 22 and 23, which have sub questions. I think some 5-6 sub questions are there in each question. So there are around 10-20 questions are remaining from this chapter, which we are going to cover in the next video. Stay tuned. Thank you so much.